All righty. All right. Good morning, everybody. Good morning and afternoon to everybody. Thank you for joining us today. Got some exciting stuff lined up for today's webinar. Before we start, my name is Eric Driscoll. I work with Astera and I'm a technical account manager here at Astera. So my job is working with utilities throughout the US to help adopt Astera, our satellite leak detection technology, and maximize their services with Astera. So I'll be the one moderating today's webinar, which is the value of proactive leak detection, how Erie County Water Authority identified over 200 hidden main leaks. So exciting webinar today. Before we do get started, I just had a couple of quick housekeeping items. So if you have any questions during the presentation, please submit them through the Q&A function. We will have some time towards the end of the webinar to get to as many of those questions as we can. And we'll also be recording today's session as well. So we'll send out that recording out to everybody within 24 hours following the conclusion of the webinar. So if you have a teammate or a colleague that wasn't able to make it, you can go ahead and get that sent over to them as well. So with that, we appreciate everybody joining today, and we'll get it kicked off here. So for today's speakers, first we have Mark Bellicose. He's the distribution engineer with Erie County Water Authority. Mark has 21 years of experience in water distribution systems with a focus on capital improvements, non-revenue water production, and proactive leak detection. So very excited to have him here today to brag a little bit about Erie County and their results using Astera. Next we have Tony Popolo. Tony is the operations manager with McKim & Creed. Tony manages their water assets and leak detection operations group, and he brings a ton of experience in leak detection and water loss recovery. So we work with McKim & Creed on a variety of projects throughout the US. So really excited to have him in here to share his expertise as well. Lastly, we have Patrick Days. So Patrick is our senior sales manager with Astera, where he works with utilities across the eastern US to identify and reduce water loss using our satellite-based technology and AI as well. So he'll be here sharing his expertise around Astera and how we do what we do. So thank you all for joining us. And with that, I will kick it over here to the agenda, what we're going to talk through today. So first and foremost, we're going to start with Mark, just get some background on Erie County Water Authority, the system itself, and some of the challenges that Mark was looking at that he wanted to potentially use Astera for. Then we're going to kick it over to Patrick, who's going to take us through the satellite technology, how we get to the data that we deliver, how that data is used to then narrow down potential leak locations across a large distribution system. From there, we'll loop in Tony into the conversation to talk through what happens once that Astera data gets into the hands of a leak detection crew in the field that then go and pinpoint those leak locations. And finally, we'll look at the results from Erie County's program and talk about what success looked like from both an operational and water loss perspective for them. Alrighty, now to the good part. So wanted to kick it over to Mark. So I guess we'll start with you. So for those on the call that are not familiar, or may not be familiar with Erie County Water Authority, can you give us a little background on the utility and the system you manage?
Sure, thanks, Eric. Good afternoon, everyone. So ECWA, or Erie County Water Authority, we're a water utility in Western New York. We serve a population of approximately 540,000 people, and that covers approximately 36 municipalities. We have about 3,600 miles of pipe and about 175,000 service connections. And we distribute about 75 MGD on average. We're kind of unique in the sense that we're very similar to a lot of utilities that we have a combination of cast iron, ductile iron, and PVC mains with a small percentage of large diameter PCCP. Where we are unique is that about half of our system is direct service, meaning we own the system, we own the assets, and we're responsible for capital improvements. But the other half of our system is lease managed, meaning we are responsible for operating the system and maintaining and repairing it, but the actual assets are owned by the municipality, and they're responsible for their capital improvements.
Got it. Thank you, Mark, for that background. Really appreciate it. And yeah, we work with a variety of utilities, and you're one of those larger utilities that we work with. So that kind of naturally takes me over to the next slide here. Given that background on Erie County and your system, so I know you had reached out to work with us. a few years ago. So wanted to get an idea and an understanding of what were the major drivers for ECWA to adopt Astera and think about satellite-based leak detection.
Sure. So obviously our one of our goals was to obviously always reduce non-revenue water, but at the same time we were trying to implement a more proactive leak detection program and approach. We currently have in-house leak detection teams, but we can only cover so much ground with our system. So we have a number of different tools that we use, from our leak detection teams to acoustic loggers to smart hydrants, even condition assessment tools like Pipe Diver and SmartBall. But we were looking for something that could really complement everything and become a little bit more efficient with everything we do.
Got it. Thanks for that, Mark. One question for you. So I know something that a lot of utilities deal with, obviously in your part of the country as well, as there's that cold factor as well, those cold snaps, winter months, things of that nature that I know can put stress on the water system and kind of affect the water system. So can you talk a little bit about, how those harsh winter weather conditions kind of affect the system and how we might be able to help that problem?
Sure. So yes, I mean, weather certainly plays a role within our system. So, during those freeze thaw cycles, as well as like water lake temperatures, once they start to decrease, we see an uptick in main leaks for sure. And some of those are obviously non-surfacing in areas that are lower pressure or in bedrock. It takes, a lot longer time for us to be able to see those leaks. We typically will see within our system about 800 to 1,000 main leaks per year. So it's no surprise to us, but obviously the Astera scan allows us to hone in a little bit closer on some of those leaks and get to them before they become a surfacing leak that is not on our schedule. It's more of an emergency repair.
Right. 800 to 1,000 main leaks per year. You sure have your work cut out for you guys over there, it sounds like.
We do, especially during the winter months and the summer when there's a high demand.
Right, right. Awesome. Well, thank you so much, Mark. Appreciate that background there. We're going to get to the results a little bit later for Erie County, but before we do that, just to give everybody an understanding of Astera and how it actually works, I thought it'd be a good place to bring Patrick into the conversation. So, Patrick, with Mark, we've talked about the challenges of covering a system kind of with those traditional methods and kind of a small leak detection team. Can you talk us through Astera and how the satellite-based leak detection process works?
I can. Thank you, Eric and Mark. I appreciate the introduction. I also want to extend a welcome to everybody on the call with us. Thank you for joining. And I want to reiterate a word that came out of Mark's mouth just a moment ago. He was explaining some of the existing tools that they have in use currently, and that he finds, the Astera solution as a great complement to those tools. And I think that's a great place for us to really introduce this technology. And, it kind of lends itself well to the old analogy that we've all heard, the needle in the haystack. And understanding really from a formal leak detection program that there really are tools that can be assigned to two camps. One on the pre-location, the big picture side, and then when we get down to actually correlating and determining exactly where that leak source is, marking it for excavation and making that repair, that's on the pinpointing side. There are a couple solutions out there and devices that can kind of play in both camps, but at the end of the day, I have not seen one tool that can really, give us the proper support, the proper data, and the proper direction. So I am, a full advocate around a tool bag or a tool set, and Astera is just one of those tools. So let's call ourselves a pre-location tool. We are big picture, and for many utilities, we can be the very first step, because we're going to provide a snapshot of actual leaks detected system-wide. And from there, I'll explain a little bit about how our technology works. We're quite unique. There's three components at play that, when bundled together, create a very unique solution. One that, through patented algorithms AI infusion, and then ultimately our use of very special dedicated satellites that are in low Earth orbit, we're able to do what we do. So the first component is obviously the view. The view from space is pretty grand, right? It's 400 miles above the Earth. And from the image that you see there, we're able to, in many, many cases, image your entire system, with one pass of the satellite. So again, that creates a lot of advantage from a perspective where one of our satellites we're talking in the range of 1,400 square miles in coverage. So again, we're able to take full system imaging, process the data that comes back to us, and turn that around in 4 to 6 weeks typically. So it's a tool that yields immediate results for further action, again, from a pre-location perspective. Now, I mentioned the satellites that we have in play. There's about 6 commercial satellites that are carrying synthetic aperture radar capabilities. We are in constant commissioning on 4 of those satellites internationally. And from that, they carry an L-band synthetic aperture radar, L-band being 1 to 2 gigahertz. Now, this is important. It's just one step up from the communication path that many of your AMI systems or cellular-based systems are employing. And what it really translates to for us is a very long wavelength. And with that long wavelength, we are able to really penetrate a lot of obstructions, a lot of noise, anything from a weather perspective, cloud cover, that type of thing, intermittent rainfall and other storm events, all the way down to vegetation, down to pavements, down to even obstructions that we might find in more urban settings where we have even skylines, where we have been able to show really, really strong results in really big city environments. And then lastly, Eric, if you'll advance to, really what brings it all together is our ability to analyze a very, very complex data set that comes back to us. And we're doing that through proprietary algorithms. I would be remiss if I didn't state that, really the origin of our technology was founded in the mission to find water on Mars. And from that, it is then when we started to build these algorithms, more importantly, starting to infuse them with data. And over the last 10 years, Astera has been able to, in a commercial sense, and through AI infusion, make those algorithms incredibly powerful. So with every project we complete, you're finding, just more and more high confidence levels of detected potable water and detected wastewater, depending on the algorithm that we employ, to be able to dig subsurface and bring back results for leaks that in most cases will never surface, or certainly have not surfaced yet, have not grown to a catastrophic size or formed a visible break. So again, it's all about a proactive play here with a very big picture tool. If we want to dig a little bit more on the technology, number one is understanding how our synthetic aperture radar is unique from other radar technologies that you might employ now to find pipe, to find other assets that are buried, to maybe get better insight in areas that are prone maybe to sinkholes or other earthbound, events that again might need inspection or investigation. We're going to shift it to L-band 1 to 2 gigahertz. Again, long wavelength equals penetration depth subsurface. And then lastly, just to really give some science behind our ability to, once we see the water in soil outside the pipe, we're able to type it based on specific water signatures that water will yield through its electrical properties. So we're focusing on both permittivity and the conductivity of that water that we find in the soil. And on this graph, you can see kind of the standard, let's call that through distilled water, and that sits around 81 on a dielectric constant or a dielectric coefficient scale. And when we get to salt water, based on the salinity, that one's going to be 55 to maybe to 60. That's the red line that you see charted here. And then in between are going to be variants of that, right? We've got treated water, we've got wastewater. Again, knowing full well that those water signatures that we are uniquely looking for with our algorithms are driven by those treatment chemicals. So again, chlorines, chloramides, fluoride, that is what we're have basically built our algorithms around. And we have really gotten very powerful at being able to, at high confidence levels, be able to tell you specifically that we have seen potable water apart from groundwater, even in close proximity. So a little bit of background around the overall operation, what we can and can't do. I've mentioned we are a very unique play to dig subsurface up to 10 feet. Here I'm located in the Atlanta area. We've got very tight, dense clay soil structures here, and our customers here in North Georgia are seeing 8 feet, maybe even 10 feet penetration depths, and being able to reveal leaks even on transmission lines. So the capability is there. We're going to start our process first, as you can see, with step one. We're going to identify the area of interest. And for many of you, that's going to be your entire system, particularly if this is the first time using this technology. You're going to want to see big picture your entire system to see where you need to mobilize further those tools that Mark and I mentioned, because it's not just a one tool play here for sure. Okay, once we have determined what the AOI will be, we're going to scan. And you can see just in this image here, the ability for us to scan, again, up to 1,400 square miles really makes it a simple task of being able to encompass everything we need to and get that data processed, cleaned, analyzed, and back to us for review. When we image your system from space, we do not see pipe network. We do not see any assets. In fact, again, as I've mentioned, we're trained to go look for water. We want to look for water that is in soil, saturated, pooling, perhaps even channeling down a stormwater line trough or other feature to where we can find that water yielding that specific water signature, either treated water or wastewater, depending on what we're hunting for. And it's not until after we've done that we will bring your GIS layers into play. And then we will go through a secondary analysis to correlate pipe network versus the POIs that have been presented through the scan itself. And then how do you see it coming back to you? It's going to come back in the form of highlighted segments of your pipe network. And again, we have, really been successful with passing the baton at this point to a crew with acoustic leak detection equipment to walk this particular POI that you see, offered in this image here. But again, when you get the initial scan, you will see a map of your entire system and every possible POI that we have detected, we have verified, and now we have presented or going to show on that map, much like you see here. Again, highlighted segment of your pipe network. Lastly, I want to really just talk about, what the deliverable outside of those POIs really is from an ROI perspective. We can't guarantee the confirmation rate, but we can guarantee that you are going to be extensively more efficient in everything you do around proactive leak detection using this tool as really a first step, as a big picture, so that you can then mobilize the resources that you do have. Mark mentioned at the beginning of this call that he has got active crews that are trained and really, really good on the equipment they carry. He's also got on the other, loggers, correlators, and even on the wastewater side, mentioning, floating and either tethered sensors. So again, all of these tools really work together. They help to complement one another. They create yet another layer that can help create focus, confirmation, so that when you do send crews out specifically to a location, you've got a lot of data backing that move and a high confidence level with our tool to know that you are going to be able to confirm that leak, mark X for excavation, and repair that leak. Because all of you on this call know, unless we make the repair, nothing else matters. At the end of the day, we can promise dollars saved, gallons saved, but we've got to make those repairs to fully realize it. And again, our software platform will allow that investigative process to go really smoothly. We've got a lot of icon-based and layer-based guidance there so that you'll know in a snapshot kind of really where you are system-wide from the whole investigative process.
Thanks so much, Patrick. That was super helpful. And yeah, as Patrick alluded to, so one of the big operational benefits of using a tool like Astera is that for us, when we deliver you the data, is we want to hone down your system to 5 to 10 or 15% of your water system. And the reason being is that we want to make it so that you are spending more time in those places where there are likely leaks occurring underneath the ground and less time searching through those spots or areas or having a team walk the ground of those areas where there probably isn't a problem happening underneath the ground. So it's kind of what this slide here alludes to is typically we see almost a 10 times the production of field crews that are going out and doing the investigation, 10 times the amount of leaks found, and just a portion of the pipe that we're able to cover using Astera and that we highlight for you guys. So awesome stuff, Patrick. Thank you very much for the background there on the technology and how it all works. Super, super helpful. So he kind of alluded to it as well, but so we can hone into kind of an area for you. So it's typically going to be one of those POIs that Patrick said, which is 1 to 2 block radius. So after we get that data to you, that POI, it's really important to actually have a team go out there and do the field investigation. So we can give you a general idea of where those leaks are popping up in the system. However, we really need somebody to go out there and kind of mark that X on the ground, really pinpoint that leak using that acoustic leak detection equipment. So with that, I wanted to now bring in Tony. So like I said, everybody has to go in and actually get into the field and put an X on the ground. So Tony, we've worked a lot with your team at McKim and Creed, and you were responsible for the boots on the ground investigation for a portion of the project with Erie County. So just wanted to get some insight from you, when you receive Astera data, kind of what does your process look like in the field and what are you looking for?
Yeah, thank you, Eric, and thanks everyone for tuning in today. So it's really great. One of the very first things that we do anytime we're attacking a leak detection investigation project is align with the utility and what their prerogative is and kind of outline where the focal points need to be. And so with an Astera project, it really helps in that process because Astera, like Patrick mentioned, has continued to get better over the years. And they not only now give us these areas of interest that make a leak detection investigation significantly more efficient, especially when we're talking about systems the size of Erie County, where it would take years for a team or a few teams to cover that entire system. We can now do that in a fraction of the time with higher producing results per day of investigation. And so with that, our very first approach when we collected or received the data from Astera is to meet with the utility group and talk about where those areas of interest have been found in their system, how we prioritize those, using the strength of information from Astera's POI generation. They're also able to help guide that so we can prioritize areas with higher likelihood of leakage being detected as priority in the system so we can attack those first. Generally, that turns into larger size leaks. So those areas have guided us to areas that potentially are going to have a greater impact to address earlier on. And then also making sure that we're attacking those areas that have utility insight, right? The utility knows better than anybody where their system has its strains and issues and historically have had leak reoccurrence and things of that nature. So working with them on the front end to discuss the areas of interest that have been highlighted from Astera, where we want to begin that process, how we want to implement the boots on the ground field team schedule so that we attack those areas that could be the most impactful first and foremost. And then from there, we go and we meet with the utility on the in-person level, so we can talk about what the day-to-day investigation methods will look like. Talk about where our teams will be out, what they look like, what we'll be doing in the field, and how to communicate that with their end user water clients. And so once that has been established, we hit the field and we start actually putting boots on the ground and investigating these areas of interest from Astera. And what that looks like is generally we'll work through every one of the areas of interest, touching every single asset that is available to us to inspect for leakage. And so it really is sometimes system by system different in how we approach some of that. Some systems that are majority metal, like up in the Northeast with Erie County, that noise is going to attenuate much farther than areas that are predominantly plastic natured pipe. And so in some of those ways, we can build in efficiency by knowing that and in hitting, less frequent assets within those areas of interest to then cover more ground even further, and then know where we need to take more of a comprehensive approach, especially where there's areas that are lacking infrastructure for your traditional acoustic methods of investigation. So you'll take more comprehensive approaches with those, such as walking over the lines with intermediate sounding with a ground microphone or a probing rod, as well as conducting hydrophone correlations for long spans of areas without assets, especially in large diameter or plastic natured pipe. And so the ability to pair the satellite points with our boots on the ground, making our teams more efficient, overall makes it that much more exciting. And if you talk to any leak detection inspector out there, a day without finding leaks is not a very exciting day, right? All of us are driven on finding those leaks, and using the Astera satellite data has put us in that situation on a much more recurring basis to be impactful and make sure that the time we're spending out there is turning into reporting leaks that can then, again, what Patrick said, most important part, be repaired and rectified so that water is captured back into the system. So one of the things I did want to point out is for this individual project in Erie County is there's a lot of different challenges that come along with conducting acoustic leak detection in the Northeast or in the North in general. A lot of times these pipes are deeper in nature because of the fact that the cold snaps that they happen in those areas can infiltrate that ground a little bit further. So they bury their pipes deeper to help insulate from that. There's also the makeup of how these systems are designed with infrastructure for customer metering, typically not being out in the right of way, which is what you see a lot of times in the South. These are actually inside of residents' homes. And so that provides a few different challenges from an acoustic investigation standpoint is we now lose the visibility on that meter showing us, is there a leak somewhere beyond what could be considered the utility responsibility? And are they getting paid for that leak? Normally in these northeastern areas, we see a gray area of infrastructure that is utility water that could be lost, but it is customer client owned as from an infrastructure standpoint. Generally, that's somewhere beyond the customer meter in the south, or in the north, the curb stop to that individual service line. And so the good thing about Astera is it picks those up. It picks up saturation in general. So much more so are we seeing the service line leakage as much of a factor on non-revenue water in the Northeast as we are just mainline leakage. Now, this project individually didn't have a whole lot of the service line issues that we see in those kind of situations, and a lot lower main leaks, which is really an indication of the ability to hear noise on those mains without that interruption from service line material or service line leaks impacting our ability to see those larger leaks first. So, we take the approach of investigating every single asset out there. And then once we identify where that leak noise is being sourced from, we take the pinpointing processes to correlating and ground miking over the area so we can put that mark on the ground. So that the utility can come and make those repairs. And then even beyond that, once those repairs are made, a lot of times we see secondary leakage in these zones. And so we will, come and follow up behind those repairs to make sure there's not additional leakage in there that we need to pick up and remediate. Sometimes we're also seeing that on rescans from the Astera satellite side. We will see a POI show up and then show up again on a subsequent scan because there was additional leakage that maybe showed up after that initial repair was made when the system was repressurized, or was a secondary leak that was not able to be identified during the initial investigation because of the first mainline leak that we saw, maybe overpowering it from a noise standpoint. And then as we kind of go further into the makeup of the system, right, this is a large system like Mark had outlined. And with larger systems, we see the strain of high usage periods during those summertime moments where a lot of people are influxing their use of water for irrigation and for pool filling and things like that. That puts a strain on the system, as well as just the inner workings of how multiple pump stations and water treatment facilities can impact pressure spikes and things like that. So with large systems like that, it's important to have that reoccurring evaluation of the system. And so seeing those scans come through in multiple times of the year at strategic moments, like Mark outlined, when we see those, capturing those leaks before they turn into major issues is really a key component to not only the utility schedule and not having to react so much in the moment, but driving water loss down, right? The only last part I want to kind of outline into our attack of non-revenue water or leak detection is that sometimes the water that we see creating the zone hit from Astera necessarily isn't happening within the zone, especially when we get into some areas with hillier country or elevation changes. We take a little bit more of a approach to attacking outside of those areas of interest uphill in different directions, because sometimes that water could be traveling down and pooling and saturating an area down below it that causes that scan to hit. So we go outside, and there have been many times we found leaks that were just outside of the area of interest, but could definitely be pointed to as the culprit as for why the water was saturating the area it was and picking up on that satellite scan. So hopefully that helps explain some of the boots on the ground perspective and approaches that we take for following up on the Astera areas of interest.
Yeah, thanks so much, Tony, for your expertise there. And like I said at the beginning here, we worked with Tony and his team on, I think, probably around hundreds of projects here in the U.S. So really have a great understanding of Astera and our data and how to go about best investigating a POI as well. I think another benefit for utilities with having you guys on the ground, Tony, is the opportunity to just shadow your team as well. I know we've done that for quite a few projects of just having their team, their operators, go out and just follow along with you to kind of figure out how do I do a very thorough point-to-point investigation, and maybe pick up some tips and tricks around what sort of equipment you recommend as well, since a lot of utilities may be looking to adopt a long-term leak detection strategy with their own equipment. So another benefit of having you guys out on these projects, and like I said, appreciate the expertise there and the input. Awesome. All righty here. So here we go to the best part here, I'd say. So coming back here to Erie County. So we talked a little bit about, why Mark brought us on board, what he was looking to get out of the service. Patrick and Tony went through their process around what the Astera data looks like, how we actually acquire that data, and how we deliver it to the utility, and how we go about investigating that. But it all comes down here to the results. So for Erie County, we had some pretty stellar results here. So you'll see kind of a map on the right-hand side. That is pulled from our EODiscover platform. So Patrick alluded to it a little bit earlier, but throughout the project, we're going to basically have a platform for you to engage with. So we don't just send you the data and leave you high and dry. We're going to be there to help you throughout the entire process. We're going to help you prioritize those POIs, kind of what Tony talked about, figure out those areas where you're like, hey, we have a POI here. We want to go out and investigate it first and foremost. We'll be there to help you kind of sift through that data and figure out where you want to start and end the investigation. So that's what the map looks like there. And then on the bottom there, you also have some reporting as well. So we have reporting in our dashboard, and then McKim and Creed 2 also has some very detailed reports that they will send about those leaks that were found. So your team can basically have those and go out and make those repairs and get that water back into the system. So swinging it around to Erie County, so for their project, there was 661 POIs that were investigated. There was 287 leaks found, and 210 of those were main leaks. 14 were service leaks, and then 3 were customer side leaks. And then we also had about 60 work orders as well. So to just stop on that point too, so one thing we'll actually do after you receive your Astera data is if we have a team going out there and doing the investigation, we of course will have those leaks come into the platform. However, you're still going to have a subset of leaks that are getting called in or are coming in via work orders, are basically coming in outside of that investigation that McKim and Creed or another team may be doing on the ground. So what we do is actually just work with you to get those work orders uploaded into the platform so we can actually track, hey, we took our scan and we actually had a leak pop up in this area. It wasn't necessarily somebody that found it or investigated it, but it did pop up. We always like to get an understanding of where those leaks are so we can correlate, the ones that were found within those POIs there. So that's what I'm talking about there when I get to the work orders. But for the estimated water savings there, around 1.24 billion gallons of water is what we estimated from all the leaks that we found there in Erie County. Really exciting number there. Just to give some context to that, enough water to power roughly 23,000 U.S. households for a year with that water back in the system. So very excited to see that there. Estimated over $1.1 million in water cost savings. So that's something too, is that we'll work with each utility, get an understanding of your water costs and how you actually measure the ROI of a service or project. And then we can incorporate that into the actual platform itself so that throughout the duration of the service and the project, you have an understanding of, hey, we invested so much, how much money are we actually getting back into our pipes with our water savings? And then Mark, wanted to pull you in for this. So I know you discussed, some of your happiness with these results here, and then I know some of the operational benefits there around the leaks that we found and the water that we were able to get back in your system there. So I wanted to hear just a little bit about some of the operational benefits you saw there outside of these numbers here, and then also I know you mentioned decreased plant production. So any insight on that you noticed the results of the project?
Sure. So originally, I know you guys had asked, when we first did the scan and the points of interest came in, there was kind of a question if we were surprised. I think for us, we have a large number of water main breaks annually, and I think it wasn't so much surprise for me as it was skepticism. We look and we see over 600 points of interest, and you start to wonder, which ones are truly leaks. But I think our confidence built pretty quickly as we started to investigate, and McKim & Creed did investigations, and we started to pinpoint leaks and then dig and actually repair many of the leaks within the system. You start to become pretty confident in the technology. With regard to operational benefits, I mean, the biggest key for us is we saw a significant decrease in non-revenue water. It was about a 6% decrease. And we actually saw a decrease in our plant distribution of about 5 mgd once all of our leaks were repaired. So it was a pretty significant change in our system.
That's awesome. Very exciting to hear that. Thanks, Mark, for that insight. And yeah, so it sounds like I know you guys brought on some additional scans. So for you, I know looking to get some more insight into the system over the next year or so as well. So very exciting there. And that's something too that I think Erie County did very well is, you guys really utilized the opportunity to get a full look at the system, even multiple times per year. So that's something that a lot of utilities will use Astera for is, hey, we have a lot of mileage here that we want to cover. We want to get some insight into what's going on in the system, whether it be a scan in the spring or a scan in the winter or both of them. So we offer the flexibility, and Erie County took advantage of, getting multiple scans to kind of get an understanding of where these problem areas and these leaks may be persisting throughout the system. So thank you very much for that insight, Mark. Very happy to see these results and happy that we were able to help Erie County get some of that water back in the system and save you guys on water and then also money and just help kind of streamline things operationally. That's always really excellent to hear. So appreciate that.
Thanks, Eric. Appreciate it.
Alrighty, so that concludes today's webinar. We do have the Q&A coming up here in a second, so stick around for that. But really appreciate Mark, Tony, and Patrick for jumping on, sharing their expertise, giving us some insight into what they do on a daily basis, how we're helping utilities get water back into their system. Their contact information is here on the screen, so if anybody wants to follow up after today's session, please feel free to reach out to any of us or any of them directly. And we've also had some questions coming through the presentation, so I think we'll take the next few minutes here to go through some of those questions, and more than happy to get those questions answered. And then following today's webinar as well, if you have any questions that happen to pop up, please don't hesitate to reach out to any of us. We're more than happy to go ahead and get those answered for you or have a discussion with you. So with that, we'll move on to the Q&A here. Just pulling it up quickly. All righty. So one question we have here is, should we wait until low irrigation season for the scan to avoid false readings where lawn watering is taking place? Great question. Patrick, do you want to take that one on?
I will. And Richard, thank you for the question. The short answer is no, there is no concern. So we have, through our algorithm, refined it in such a way to where it does ignore these false positives that could be created by intermittent weather. And I'm going to go back to kind of that definition. Whether it's irrigation, as long as it is not multiple days where that irrigation system does not turn off and allow for a soaking in and an evaporation to take place. If that is a situation to where we are truly saturating with nonstop water, yeah, could skew the data, but in the real world, we have experienced negligible impact from a detrimental perspective from having middle of summer irrigations, the greenest lawns in the land.
Awesome. Great stuff, Patrick. Thank you very much for that. Another question here from looks like Andre. How common is it that Astera's utility customers have very limited piping data, and how impactful is that for Astera's pinpointing on the actual leaks? So happy to take this one. So we can actually work with systems, and we do work with a lot of systems, especially utilities in rural areas, smaller utilities that don't have a full GIS layer. So while it is definitely preferred and helps us with the actual analysis, it's by no means completely necessary. So we can work with some of the alternatives there. When it comes to the actual pinpointing, though, with Tony and the team there at McKim & Creed, when they're on the ground, really helps being able to have as much data as possible around not only where those water lines are in the system, but also those assets. Because as Tony said, with their process, they're going to be as thorough as possible. So they want to listen to each and every listening point in and around that point of interest. So it's really helpful to have those in the actual system so that we can go ahead and see where those areas are. But like I said, while it is helpful, we can definitely work and figure it out without it. All righty, Benny had a question. When will the recording be made available? So probably around early morning tomorrow at the latest. And let me see here if we have any more questions here. All right. Can you talk about doing this process in a cold weather climate and deeper pipes for frost lines? So yeah, it might pull you in, Tony, too. So with Astera, and Mark kind of alluded to this as well. So a lot of stress is put on the water system, especially in those winter months due to the freezes, things like that. So typically, from my experience, having worked with utilities kind of in the Northeast up by Erie County that deal with a lot of those freezing temperatures, we actually find it beneficial to scan when it's getting a little bit colder and that system is getting kind of stressed there. So a lot of times, it's not unusual for us to take a scan in the winter or maybe in kind of the early spring when it's still kind of warming up a bit, and have that data on hand and then dispatch Tony and his team to actually go out there and do the point-to-point investigation, seeing as the pipes aren't frozen there for them to be able to listen to and pinpoint those leaks starting out in the spring. So we actually recommended and seen some great results from utilities that have decided to scan during those times where there's a lot of stress in their system in the winter time. So great question there. Anything you want to add, Mark or Tony?
Yeah, I'll take it for a minute and then let Mark kind of talk about his individual system perspective on that. But as Patrick alluded, the satellite technology can penetrate, up to about 10 feet. And so sometimes even pipe can be deeper than that. But what we generally see with the Northeast and those cold environments, with the pipes being that deep, it takes a lot longer for those leaks to surface. And by the time a leak does surface, generally you can expect, unless that was some sort of catastrophic failure, it is potentially leaking for a long time. And so the satellite being able to capture that before a leak surfaces is just able to help reduce that leak runtime. And so if we're seeing satellite data dive that deep into the ground for saturation, it means that we can visit those leaks and find them before they do become some sort of catastrophic failure. The other side of the house is when we're working in these Northeast environments or these very cold natured systems in the winters, is that we want to try to get those scans done in enough time to investigate them and then make repairs before that weather sets in. Anybody that's done leak detection out there in the Northeast knows that when there's 6 feet of snow on the ground, finding assets are a whole lot harder, more or less just the cold nature that you have to work through. And so, when we can have access to those assets a little bit easier without that snow being piled up, we can then, investigate a little bit more efficiently. And also for repair crews, it makes it that much easier for them to get out there and make repairs before that cold weather sets in. When we dig those pipes that deep up, that cold weather can definitely cause an issue with, getting wet and having, safety concerns, but also exposing piping to extreme temperatures that could cause other issues. One of the other things that is very, aware of what Mark is doing with the reoccurring scans is when we come out of that cold season, being able to do a scan at that point so we can capture those leaks that potentially did occur during the cold season but never did surface. You're again going to capture those with a scan, seeing that saturated soil, and be able to find those faster before we wait months for them to surface and cause, the reactionary process. So that kind of dual scan approach for these type of systems fits really, really well.
Yeah, I think Tony and Eric definitely touched on that. Tony, especially your point about when we did the scan. So for us, we had a couple winters, this past winter especially, where we had some pretty significant freeze thaw cycles. And I think, allowing us to do a scan in late spring, early summer allows us first to be able to pick up any of those non-surfacing leaks through the scan. But second, allows us a good time in the year for McKim & Cree to be able to come out and our teams to be able to do investigations. And a lot of it comes down to, like what Patrick said, ultimately we need our line maintenance department to be able to have the time and resources to be able to repair these leaks. So we position it timing wise where we can complete all those repairs in a timely fashion once we pinpoint them.
Awesome. Thank you both for the insight there. Super helpful. All righty here. So let me go to the next one here. How deep will the radar penetrate? Patrick, I know you talked about that a little bit in your section. You want to just cover that really quickly again?
I can. Thank you, Eric. Yeah, we say up to 10 feet typically. In very arid, loose, sandy soils, we have found even better success from a penetration perspective. But in the U.S., I would say we kind of hold to that kind of 8 foot to 10 foot level. And Tony, I appreciate your comment around catching those leaks as they start to surface. We are getting in front of that whole process probably months before they actually break ground and become visible. So there's a story to tell. There is some capillary action that's happening. Leaks don't always leak upward, but at the end of the day, we do benefit in some of those slower leaks where they are showing themselves at pipe level or maybe a little above pipe level as some of them try to work their way towards the surface. So it's it is certainly a way to be proactive and to limit that run time for that leak as much as we possibly can.
And I'm happy to jump in there because there were some really good examples from this project and many others that we do where that leak never surfaces. It finds a route to its least path of resistance. And so one of the ones we call a double impact was hitting a sewer drain, right? So the sewer system is taking the brunt of that leak, so it never does surface. One of those can go on for years without proactive approaches. And then more often than not, that utility is having to pay for the treatment of water that's already been treated. So it is a double impact on the revenue side. So those are even more impactful, and finding those are really tough because they may never surface until there is some sort of catastrophic failure.
Yeah, very helpful too. And along with the pipe depth, or sorry, the scan depth as well. So typically we see as well, these leaks will find the path of least resistance, which Tony kind of touched on there a little bit too. And typically that's up in a lot of cases. So, that 10 feet of scan depth gives us some pretty good depth into the ground there for the actual scan and getting the data for you. But even if there is a leak that has originated, within that or just past that depth, a lot of times, of course, we'll still pick it up with the satellite scans themselves. So awesome question. Thank you for that. We will go to, does concrete reinforced roadways interfere with scan capability? So thank you for the question, Sarah. I'm happy to take this one. And this is a question we get a lot. So the actual L-band synthetic aperture radar that we use is pretty resilient. So I think that's kind of one of the biggest benefits about that technology too, is that it's not really thwarted by any sort of weather. So cloud cover, trees, canopies, all that good stuff really doesn't matter. The scan is going to penetrate through the ground there. The only thing that is really going to affect the actual scans, or can affect it, is a lot of metal. So I'm talking like a lot of metal. Typically, those will act as sort of a mirror. So the actual scan will typically tend to bounce off metal. Another thing is water too. So standing water, funny enough, is pretty difficult for the satellite to penetrate through. Like I said, it essentially just acts kind of like metal, in that it just kind of reflects off of that standing water and goes back to the satellite. So we do get the question about, hey, what about surface leaks? Are you guys picking those up? Well, it's going to actually, if there's standing water at the top of the ground there, it'll bounce off that water. However, we're still picking up the soil saturation that's happening and causing that standing water around that particular area. So yes, there will be a mix of, we're probably going to catch mostly on those underground leaks, because that's what our technology is really built for. But the great benefit of this technology as well is that, and Mark kind of talked about it too, is that you will find those leaks that have peeped above the ground as well. And that's a great benefit too of having a team like Tony's go out there and do the actual leak detection investigation. Is when we take those when we take the scan and deliver you those POIs, we're going to deliver POIs in areas that maybe you haven't checked out in a while, and you're like, hey, we forgot we had pipe here, stuff like that. So we typically see that with some utilities as well. So the great benefit, or kind of side benefit, of using Astera is that you may be hitting those areas of the system and giving them some attention where the team hasn't been out to in a while. And with that, we can also see that a lot of times there's some pretty significant leaks in a lot of those areas. So just another secondary benefit of using Astera, I think. Thank you so much for that question, Sarah. But no, in short, concrete reinforced roadways shouldn't have a problem with the scan data.
I will add that acoustics under concrete are a lot tougher. So concrete is something that deadens noise. And so it is one of the things that is an impact for being able to acoustically confirm that that leak is in that location. We may hear it on assets, and our correlation may place us in that area. So that's why it's important to rely upon those many different technologies to confirm the exact location before that excavation takes place.
Awesome. All righty. All right. Perfect. So I think we covered a good portion of those questions there. So with that, I think we'll wrap today's webinar. Really appreciate everybody for jumping on and tuning into the webinar. As I said at the beginning here, let us know if you have any questions. Feel free to send those questions to Mark, Tony, Patrick, or myself. And then along with that, we will send out a recording of today's webinar by tomorrow. So you'll have that in your inbox. Like I said, if your team or anybody wasn't able to make it and you want to go ahead and get it sent over to them, you're more than welcome to. So thank you again all for joining today. Thank you, Mark, Patrick, and Tony, for jumping on and sharing your expertise. And yeah, very much looking forward to continued progress and success in Erie County. And everybody have a great rest of your week.
Everyone.
Thank you, Eric. Thank you, Mark.
Thanks, guys. It was a pleasure.